Alright, what's up, people? So I'm gonna get in an hour today, super late stream, been busy doing other life things, really important stuff actually. Uh, but I don't want to go too long without coding. It's been 5 days or something since I coded last. It was the 18th and today's the 23rd. So yeah, it's been a minute. We're gonna do a little hour today. Minute. Let's do this. See where we left off. So we had begun game testing to ensure most recent changes didn't introduce new bugs. Deadline in things. Do that. Let's open up things to do. Go to line 15. Okay. Test before changing anything else. Finished game test debugging. 24. If choose multiple cards, re-entrant lock to true. Because that was what we were dealing with in the last session. Was the entrant locks have they don't have a locked method. Regular locks do. So the question is, how do we solve that issue? Let's open up the terminal. So Control E, select our interpreter. See, I am not actually sure. So I guess we use that one. I probably need to update Python. So we need to restart Python. Yeah, I probably need to do an actual Python update. I should probably keep up with that. It's been a while since I did that. On my things to do list. Put it under. Okay, so this is going on here. Okay, I see. This indentation. This like that. Okay, here we go. For shared. Why did? Oh, I accidentally included that. This. And then this. Add. Update. And honestly, that is just something I still like. When it comes to this sort of thing, really keep up with like the development and stuff. Like I really should. Releases and all that is coming and the changes, but for now, to 5 control tilde, there we go, that opens up the terminal. If you do control tilde, it use that more often because it's very helpful. Okay, so let's up our 3 terminals to where they're nice and equal. Close enough anyway. mean, that's close, right? Alright, so CD to Canasta, and we'll copy that and go down to the next terminal, and we're gonna do that for the third one as well. So let's find this re-entrant lock. What line is this actually? Well, we'll just search for it, doing Control Shift F. And we may have like gotten rid of that. I don't know. Let's see. So let's look for just if change attribute list SS acquire this lock. Okay. And this is the line that we were talking about. If choose one of the cards re-entry lock is locked is equal to true. Yeah, so this actually doesn't exist. There is no such thing as the locked. Doesn't exist. Which means we have to go ahead and upload this bad boy real quick. Or paste in our link to the stream, rather. Uploading it. Make sure it works. Okay, it does. Alright, cool. So let's what am I doing here? Alright. So yeah, if self choose one of the cards or entrant locked is equal to true, and we can't actually do that. So what we can do is what we were gonna do before, and I remembered exactly what I was gonna do. It's basically asking if SSCS is SS. It's really all it's asking. Same difference. So we'll just paste that in. If change attribute list.ss or CS is equal to SS, that means we did acquire the lock. So that means we're gonna release it. Easy. Okay, so that was a super easy fix. Now I wonder, let's see, and this is why I use the re-entrant lock namespace for re-entrant locks, is because now I can see, did I do that anywhere else? Really do is do, see if I see, so I do this for a lot of these actually, but okay, it's test files and stuff. So I'm pretty sure we don't have that going on anywhere else. So we're gonna crank up the server. We're gonna crank up the clients. We're gonna crank up the other clients. And let's see what we can get. Is it gonna work? Oh, well, there goes our waiting other player bug, which we have to fix. We're worrying about that another time because, well, I'll fix it one day. One day I'll fix it. It's just that it's so rare, like, you know, it's really not worth worrying about right now. I'd rather just fix everything else, and I'll probably just do that like dead last as far as bugs go. Okay, so it is working. We do have our delay in place, which we're gonna remove. Uh-oh. Well, see, that's the weird shit going on with the regression text. We need to fix that as well. It's a huge problem. But oops. We don't need paint right now. little too slow here. Do we have live logging enabled? Okay, yeah, we do have live logging, so it's logging all this all these events as they are occurring in real time. And I'm pretty sure all I'm doing here is I'm just testing to see if the behavior is as it was before I made any changes, which means there's still going to be some bugs, but not any new concerned. Alright. So the real question is during play cards. That's when it gets ugly, usually. But we did fix several bugs with play cards. We fixed the draw, like the highlight click card bug. We fixed also like a game breaking bug that was related to, what was it? It was the card group name, I think. Damn, I can't even remember exactly what it was. That's why it's good to keep track of your bug, like solving logs and everything, so that you can remember. Okay, so say no to this. If you can't remember, you can look at the logs that you have. Damn, I remember there was a few things I suspected that it was, but I ended up like finally figuring out that it was something else. Oh, okay, I remember. It was actually it wasn't card group name. It was related to the Y not being, the X and Y not being perfect. I'm trying to remember, how did I fix that actually? How did I fix that? Damn, I'm gonna have to remember that because that's kind of important. How did I fix the... Oh, okay, I remember. Yeah, I refactored. Okay, it's coming back to me now. See, this is why, like, when you take time off, just a few days, you know, I kind of like fell off. I forgot, you know, where I was at as far as what was wrong, what just got reworked, which code got reviewed, etc. And we reviewed and like refactored some of the stuff associated with the event handler, with choose multiple cards, click card active, etc. We modified lots of that we found, like some places where we can make improvements. And what else did we do? We also did well, I think that's basically it, honestly. I think that was what, like, the last thing we changed. I can go look at the devlog and see. I think I need to look at the devlog and read just to see exactly what it says. And that's another benefit of having devlog is if you forget, you have it written down. Note taking is one of the most important things in programming, in my opinion. Comments and stuff, code comments and all that, and then also just note taking in general about where you're at in the project and what problems you're dealing with. Okay, so this is our third playthrough and jabbing at the jaw to pass the time, and it looks like everything's as it was. It works. So yeah, this is actually good news. Still kind of clunky with the movement and the progression text and everything because of like data transfer and stuff. But this is just, I don't care about it stuff. Is finishing this project. or basically getting it bug free, you know, and then I can fix some aesthetics, because maybe some of the aesthetic issues are caused by just bugs. So if you fix the bugs, you'll fix the aesthetics, you know what I mean? You don't want to try to diagnose a problem over here when it's actually like somewhere else, you know? You can spend a lot of time spinning your wheels. You can spend a lot of time spinning your wheels like that, and it's just dumb, honestly. Really dumb. Wasted lots of time doing that. Started to feel like this project is spinning my wheels, but I don't actually believe that. I'm glad that I made it this far. Okay, so let's try discard, see if discard works. I usually don't do discard. I just want to see if we get a crash or whatever. Maybe it'll show us our next bug, where we want to focus. So let's get rid of the 6. It highlighted all of the proper cards. Got rid of the 6. Alright. Now it's the other player's turn. Okay, let's see if it works. And now it's M's turn to draw. So this is the farthest we've ever actually played through the game. Online version of it. We've never played through this far. I never made a player discard and the other player made a play. So let's see if we can do that. We'll break a little record and then we'll get back to our things to do list. So let's click all these. Clicky, and just got the better hand here. I don't know, I think J's got the better hand. M's hand is looking kinda, well, it's not terrible. He's got some aces. Aces are worth 20 points a piece, so they're like worth more. He's got a joker. He's alright. Okay, so we'll just say no for him as well. We're not going in depth into like the wild card stuff. We're going to test that after. I'm just kind of trying to make it through a general basic playthrough to test card movement. And see how much smoother that is? Why is this card movement for this guy so much smoother than the card movement for Jay? So how much faster and everything that was. So there's something up with that. That might be a bug where one player's card movement is not smooth and the second player's card movement is very smooth. I wonder why that would be. Let's do one more just to see what happens. So let's click all these cards. He's gonna just play everything again. Actually, you know what? I'll leave out a card this time. I usually don't do that, because usually playing all the cards gives me like, it's more like stress on the code, I guess. I don't know if it's just me, but it seems like these cards are moving. You see how smooth that is? Yeah, I'm imagining that. I don't remember Jay's card moving all smooth like that. They're and like in their movement. It's where M's are and fast and all like faster. It's probably a little bitty bug. That's probably like one just like little thing. It's probably a little tiny thing in card movement function or something. But anyway, we're not worried about that. We're worried about big things, not little things. So we're gonna kill that script. So we didn't encounter any no crash bugs. Let's see if we got the other exceptions, but usually those result in some sort of visual display error or something that's readily apparent or that crashes the script, which is surely apparent. We didn't see any of that, so it looks like we're in luck. Okay, we did good. So we tested before we do anything else. Fixed that bug. Like some of those little bugs, you don't really need to like document. It's good to document mostly everything, but you don't have to document every single thing. Let me look at this. Let's see what we did. Go back to the 15th. So we continue the implementation of reworked click card logic. Same thing again, and associated attributes and sections. Okay, yeah, that was all event handler and stuff. The 16th, we finished the rework of said sections. We finished that event handler section. We tested it. Finished debugging the second attempt bug. And what caused bug? That was I don't remember. I guess that was the cause of the play attempt bug. Use multiple cards, click card active stuff. I'm just trying to remember everything, you know what I mean? So I can like get all the pieces back. It's part of the puzzle, but okay, so 18th, we finished ensuring places and setters getters that utilize the lock have them acquired at the correct location. We reviewed all internal use attributes to verify we aren't modifying accessing them outside of getters and setters. Since race condition prone instances of these need to be locked. We triple checked manually locked acquiring and releasing locks to ensure logical security. Triple checked manually locked acquiring and releasing. Okay. I remember that. Began game testing to ensure most recent changes didn't introduce new bugs. And, okay, so that's where we stopped, and verified no new bugs. No new bugs. That's what you want to hear. Okay, so next up, we're gonna do here. Objects among others. Okay. Realize that we actually need to check for shared objects among non-attributes since we already checked all adders. Okay, they are just as prone to race conditions that need to be checked. Don't forget class instance. Objects such as P1 game. Also don't forget when these objects are accessed via self. Okay. Then we have the list of objects, card instances, client 1, client 2, and we checked inside of each file for other non-class instance objects. Okay, yeah, we did that. I remember doing all that, and that's finished. And we need to take care of, alright, so now I've been avoiding this, I guess. This would need to be done. Check for shared objects among non-transferred adders. Okay, so we have to check non-transferred adders because we realize that those also can have thread contention between C1 thread and C2 thread. True. Okay. So I guess we'll start here. We're gonna look at the card instances. So what we're doing is we're determining whether or not the card instances are prone to race conditions. Okay, so let me think, how can I do this? Alright, so well, think probably are. They probably are prone because they are modified on the main thread. Let's open up the file hard, and they are dirty sprite. They inherit from that class. But the only 3 attributes they actually have is display layer, X, and Y. Now display layer, X, and Y are all properties, so really the shared attribute would be the internal use, which would be underscore display layer underscore X underscore Y. But the thing is, we only modify well, I can't, that's not completely true. This one's like, there's a lot going on with cards, okay? Obviously, it's a card game, so there's a lot going on with cards. This one for a little bit. And try to make an educated determination here. So this is, we're gonna just, let's take it slow. Let's go through one by one. Okay, so transferred adders, non-transferred adders. Don't need to worry about this. Layer section, okay, this is where you assign some inside the card in it. Right. So this is whenever we are transferring the card group data, and you know, I just realized we could totally, like, we don't have to do all this. We could just send just the display layer and just like have a string called display layer, you know, and then it would just access the associated index instead of sending all this other stuff with it. It's really not necessary. I mean, it is a way to do it. It could be simpler. Totally could be simpler. That's something for another day, though. I'm not even going to write that in things to do. Alright, so whenever we X and Y access it to send it. So let's think about this for a second. So main thread, let's say we modify X, but that transfer only happens whenever card data transfer is true. That is only true at the earliest stages of the game. But I wonder, could that be what's causing the weird skipping movement? And you know, I didn't want to do this. But I really think I might actually change this. Like I was just saying, I don't even want to write it in things to do. But if it's touching shared attributes that are prone to race conditions, which mean they need to be locked, that is going to be like a nightmare, because we would have to use the locks. Well, maybe not. Okay, because it doesn't go off of every card. It doesn't. Yeah, it doesn't go off of every card. Like, it doesn't refer to all of the cards as a whole. They are only contested on a card to card level. Like, only the 2 of hearts is going to be contested, you know, if they're both modifying or modifying / accessing the display layer of the 2 of hearts. That card would then be under a race condition possibility. But again, this only happens, this code right here only really happens if card data transfer is true, and that is very rare. So let's actually just look up card data transfer real quick, because this is what it really hinges upon, is whether or not in this circumstance we need data transfer. I mean, we need focus. Do locks for this. Okay, so in between, let's see, data transfer is set to true before draw animation. The draw animation, let's go ahead and see what that does. I don't want to. I don't wanna, but it's gotta be done. Let's try def, the draw animation. No. Oh. Now it should work. Alright. So, what happens in draw animation concerning, well, the cards? Alright, so for current card in master deck, and this happens on the main thread, if current brings out equal to Joker, we set the display layer for each card, okay, and then we set the current card X, current card Y, okay, so well, okay, wait a second. This is not actually contended for over the 2 client threads, is it? Between the 2 client threads? Yeah, because current card currently all movement transfer happens through C1. So if it happens on the main thread, anything to do with a card, such as a display layer, the X or the Y, any change that is done there gets appended to the C1 change attribute list. Now, from the C1 change attribute list, that means, yeah, from C1 we send that data C2, C1, and C2, and that is all single threaded. So but then wouldn't there be contention between the main thread and C1 thread? Because C1 thread is gonna send it. Okay. So main thread makes the change, and then C1, well, now, then it gets the skeletonized version of the data. Gets appended to the C1 change attribute list. That gets transferred from server side to client side, client 1, client side, client 2. Now I'm pretty sure that is actually safe, because the main thread hands it off to the skeleton version, and then the client thread handles the skeleton version. Now it would be contended for between the main thread and the client thread if the client side sent data received by the C1, C2 thread, but yeah, so that's the question. So we solved the first part of the puzzle. Let's look further into this back up. Okay, so we set all this stuff, and yeah, you know, I think I want to do this. I'm gonna add this to not to pressing issues, but to non-pressing issues. And we're gonna call this, what is it? What is it exactly? It's the card group data. So we're gonna call this card group data transfer format. Noticed that when we transfer X Y and display layer data, we do so in a silly format, a redundant format. Instead of just sending the associated value, we send an entire tuple which contains all of the other data, X, Y, etc. Change it to just send the pertinent data along with a string designating which data it is modifying. Simple fix. And we might need to do this if the cards end up being race condition prone, if they are not race condition prone, it would still be worthwhile change just for added simplicity. Yeah, less code is better. With in general, like on a larger scale, not just like on the macros. Like a really complicated one-liner is not better than like format of it that's way easier to read. But in general, yeah, it's better to do it that way. Less is more. More simple. More better. Alright, so it changes, the display layer changes the current card X, current card Y in a redundant way, but as far as being race condition prone, it doesn't think that such. So let's go back to r.data transfer, that section here. Alright, so we call the draw animation, and let's see if we do anything else with the cards here. So I think really what matters is if we we change it on the client side. If it doesn't get changed on the client side, then we don't have to worry about it, right? Isn't that true? If it doesn't get changed and transferred on the client side, we're good. So display layer actually doesn't have, it only has 59 results, so I'll look at display layer. I just feel like I should look at that one. So this is in the card file. This is the setter. Okay. We use int here because it runs when the closest whole integer value. The chances will be equal without doing this versus nearly 0. Okay, so this is nothing. We don't have to worry about that. Okay, so this is in dir check, and this is for receive. Yeah, so this is what I was talking about. This is redundant. Like, this is... You don't have to do that. It's only one of these should be reassigned, not all three of them. I think that actually probably causes visual... I mean, it might not, but it might. And it's just redundant. It's dumb. There's no reason to do that. But as far as being race condition prone, this in and of itself would only result in a race condition if the client itself actually modified the display layer. So this is in card movement. Card movement gets called not in association with the beginning section of the game, right? Why did it leave this open? Okay, so we have data transfer true. Look at the draw animation. wait a second, wait a second. I think we should probably set data transfer to false immediately after this, and I just now realized this. This might not necessarily cause any bugs, but technically, since card data transfer is equal to true, that means even after we do the draw animation stuff, which doesn't use append to make XY changes, which is usually the case, which is why we have Boolean in the first place, this other stuff that goes on, well, let's see, like for instance, this right here, when we append to the hand and pop from the master deck, any X, Y changes and stuff, display layer changes to the card is going to, which this line would cause that to happen. It's going to transfer that data even though the append is already going to transfer the pertinent data. So it's like double sending. See what I'm saying? So this is actually dumb code as well. Let's see, when does it get turned back off? So we go where we have it, that append, so that's like prone to issues. It's just not optimized. Okay, and then we have return draw card. And in return draw card, this is why we need data transfer set. This section is because this is how we move the cards to the deck. We just directly change the X, Y values of the card. Yeah, so what we're gonna do to optimize this, I should have done this a long time ago. I don't know why. And I don't have an issue with this. With just set data transfer to true. It's just weird. Like, why do I do dumb stuff? Why? Say maybe there's a. I'm pretty sure there is. True. You make your XY changes that don't rely on an append. You set it back to false immediately after because you only need it to be true for this. That's it. Why would you leave it true for all this stuff? Smart. Okay. Let's be smart here. Where did it go? Where did it go? Okay, so after this, we're gonna set this back to false. So we have card data transfer set to true, and then we set it back to false right after. And that, Mr. Mac, I need to cut that out. Alright, so let's test, because we just made a little minor change. I just want to make sure I didn't screw anything up here. Things that like probably don't cause bugs but could cause bugs, like, you know, just closing like windows where errors can happen. Just like close them all, close all those windows, get them shut, and then everything will be happier. Everything will feel safer. See that card skip across the screen? I don't know. I don't know what's up with that. But it's something. So that right here, those two card movements, that's what I was talking about. That was prone to double sending of that data. So like it technically it should have been sent twice, because when we call, oh well, actually, why is it still waiting? Actually, whenever like, so we actually did add in a safeguard. I forgot about this, but server side we added in a safeguard to where card movement and stuff doesn't actually even get called. So basically, like, that append that I was worried about wouldn't have been still smarter to do it the way that we did. Have it run this pertinent section and then set to false. If you get away with not running it, not doing it like that, and then just setting it to later, it works, but it's still dumb. It's still just, it's not good practice to leave a Boolean switch turned on like what you need it. It's just like, it's like wasting electricity, you know? Sort of, you can think of it like that. If the leaving the light on could cause bugs, then yeah, don't leave the light on. All right, so back to the overall question of card instances, and are they prone to race conditions? And I'm just trying to, like, I'm worried about whenever we append cards. But like, an append doesn't modify anything. It just accesses. What we actually have to worry about is X, Y, or display layer modification. And we already checked display layer, right? We did that. We looked over display layer. Everything was fine. I think, yeah, everything was gravy there. Move the code that assigns display layer to the location draw animation that was designed for that purpose as a proper place for it. Okay. So that's safe. Display layer is safe. We don't need to worry about that. But .x, we do need to check X and Y. Okay, so this is an update. This is an So what we're looking for is client-side modification. That's all we're looking for. So this is modification. Well, no, it's not. I'm sorry. This is not. This is access. This is access. This is access. Okay, so we're actually safe there. Okay, so this is receiving, but this has nothing to do with client-side modification. Location, so card movement. Well, actually, this is just a basic question. I think I went deeper than what I had to, because the only time X, Y, or display layer gets transferred over the network would be if data transfer was set to true. But if data transfer is only ever set to true on the server side through progression, which, like, I'm pretty positive it is, then that means client side could never send card group data information, right? Yeah. Like that's the only way that it can. It has to be enabled. So we don't even have to look at all this. All we have to ask is card data transfer. I'm glad I just realized this. I do this a lot actually, where I go deeper than what I need to by getting like hyper focused and talking and just zooming in too close. That's programming. You have to do both like at the same time. It's not an easy thing to be done. Knowing when to zoom out, when to zoom in, you know, it's not the easiest thing. But yeah, so progression is server side. Server side, it's only ever just checking it. Yeah, so there, we're safe. We already know. Bam, done. So that's one of them taken care of. Done. And, you know, I probably could have. I'll do it like this. Not say verified, because I might want to save this for like later when I doubt. You know, this is like a conducting an experiment, and you might need the data later on if you forget. You know, was this racing condition prone? Is it? Am I doubting, you know, myself in the future? Instead of having to go back and rerun these logic tests, I can just like look at the note that I left. Say, hey, we verified that it's not race condition prone. Cool. Let me just triple check. So in general, card instances are shared objects. This is true, but they're not modified. You can access 2 points of data on, you know, concurrently on multiple threads as long as the data isn't at risk of being modified. You see what I'm saying? If it's only accessed, like main thread modifies it, it gets skeletonized. Client thread doesn't access the XY. Client thread transfers the skeleton XY through card group data. Yeah, so like we just the fact that the cards get like appended and groups from other lists and stuff, that doesn't modify the card. So it's like, it would just be like if you have the number 1 and you're accessing it between different, you're moving it around. 1 is never at risk of like not, it's gonna be 1, so I feel like you're always scenario. Yeah, we verified it. Okay, so moving on, and this is gonna be what is this? Client 1. Let's see what we got for this one. So let's close all 3 of these files out. Let's open up clients, and 8 minutes left. Let's finish strong here. So we're specifically talking about the client object, and just like with the cards, accessing the client, we probably access the client a lot, but the question is modifying it. So that really comes down to its attributes, because we don't like modify the object itself, we modify the attributes of the object. So since the only thing transferred is the change attribute list and the ID. Let's get down. No. Let's not. Nah. No. Damn it. There goes a frickin' strike. Just like that. There goes a copyright strike. No. Go away. Go away. Uh, hopefully we don't get a copyright strike for that. Like, I wonder if there's a certain length. If you can go like 3 seconds and they don't give you the strike, or is it like if you just play like this, a tenth of a nanosecond. If you play 16 nanoseconds of Tiesto's song, you get a freaking cover. Maybe they give me like, maybe they give you 3 seconds, and then if you don't get rid of it in 3 seconds, you get the strike. I don't know. Anyway, I think they actually have to like review it. Like Tiesto's team has to go out and find that, and they're the ones who just make the decision. So if like I stop it immediately, maybe they'll like be nice and just like, oh, he stopped. See, he didn't actually play the whole song. He realized it and then he changed it. Anyway, so client 1, client transfer change attribute list, blah blah blah. ID, that's like, these don't, well, okay, maybe hold up, let's think about this. Oh, well, we already have locks for them. We already have locks for the change attribute list, so those actually C1 catalog, yeah, this is the C1 change attribute list is locked by the C1 catalog, and likewise C2 change attribute list is locked by the C2 catalog. So any modification to that is safe, and then ID doesn't ever get modified, so that is safe. Now, so it's the broader question of the actual client object itself. Does it get, is it at risk of being race conditioning? And I don't think so. Like, if we're not modifying an attribute of it, even though like I'm like trying to think a little deeper here about this. Like, if we're accessing it, but it all hinges on modification. If it's not being modified, and like you don't just modify the client, you know, like that would mean reassigning it, or like you modify the attributes of it, or something like that. And since all the attributes are safe, I'm pretty sure it is safe as well. Yeah, I don't think, like, if we're locking any modification of the attribute change attribute list of that object, that means any access to that attribute will always be safe, which means any access to client is safe, right? Like, I just feel like I don't think I'm missing anything there. I just wanted to make sure, you know, I'm really thinking about that, like not missing any aspects of it. It's always good to take a couple seconds and just think it over. Yeah, I don't think so. I think we're good there. Pretty sure. Okay, so next is custom append list instances. We got 3 minutes. Probably not gonna be able to finish this, but I think this is probably just gonna be generally true here. Is as long as the attributes, which there's none transferred, like, okay, well this is different, right? I think these are different. They don't rely on attributes because these are lists. So you do have to take that into account. Not just like objects themselves. This is a list object. So that means if you're accessing a list and modifying the list, when you're accessing the list, you know, which comes first, which is happening, the milliseconds, the microseconds, the nanoseconds, That's race condition. I think we probably... I'm not certain. We really have to check. It really hinges on client-side modification. But this is like hand, discard pile, deck, you know, play cards, pre-sort play cards, all that stuff. So if any of those are modified on the client side, then we would have to treat them like that. They would definitely be race condition prone. Like, yeah, almost certainly. I'm pretty positive about that. So we'll put current, probably race condition prone. Yeah, so we're gonna stop there. We got 2 minutes left, and we're gonna use the 2 minutes to stage our changes and stuff. So we'll put began reviewing instance objects to determine if they are race condition prone. Stopped at line number 22. Yeah, 23, line 23. 23 in things to do dot text. Yeah, and now we're going to stage, commit, and push our changes. So it's going to be 9, 40, we'll just say 45. So we did an hour and 10 minutes, we'll just say an hour. Well, an hour and 10 is closer to an hour and 15, so we'll say 1.25. Doesn't really matter, nope. So 9:43 to 9:45. We stage, committed, push changes. So let's copy this. Alright, we're going to go down here. We're going to cd out to the root of the project directory. We're going to do git branch to see where we're at. We are in the correct branch. Now we can do git add dot add everything. We can ignore the LF warnings. Git commit -m, double quotes, paste in the devlog, double quotes to close it. There goes our commit. We changed 7 files, 20 insertions, 14 deletions. Now we're going to do git push Canasta secondary. So we put the repo first, then the branch. So we push Canasta secondary, and there we go. Okay, the timer, I thought the timer stopped. Damn, it like wasn't stopping. Usually I feel like it stops after like 10, like did it. It was not stopping. Alright, so we pushed successfully. So now all we have to do is, what do we have to do? Okay, so we need to go to programming, projects, Canasta. Copy this one. Ignore this little warning that's going to pop up, I think. Actually. Ooh, almost made a mistake there. So let's delete the old one. This is when they have the caution reminder. Alright, so now we pasted our new local backup into the backup folder. We're checking this date here to make sure it is correct, that we just, you know, did that process the right way, and we did. So yeah, we went from 10:18 to now 10:23. That's our latest local backup. Alright guys, so I'll see you I don't know, maybe tomorrow. Tomorrow's another busy day. Got a lot of stuff going on in my life other than coding, but hopefully we can get some coding done tomorrow. I think I might be able to at least get a couple hours done, at least like later on, if not early. So yeah, have a good night.